Hey everyone, welcome to Inference Time Tactics. I'm Calvin Cooper, COO at Neurometric. We have our CTO here, Byron. Today we are joined by Charlie and Anil with Rapt AI. They are building dynamic workload-aware GPU optimization and orchestration for inference. Charlie and Anil, welcome. To kick things off, how about you give the audience a little bit of your background and talk about what Rapt is and what inspired you to start the business?
Hi, I'm Anil. I'm Anil Ravindranath. I'm the founder and CTO of Rapt AI. So my background is pretty much tech, product and tech. Before starting this, I was in the storage, virtualization space. So I was part of a startup which was in a backup data domain, which EMC acquired, and then Dell acquired EMC. And then before that, I was in more on the RAID arrays, which are the storage again. But lately with the slice of AI too. So kind of what made me to kind of move into this problem or pick this problem is as I was working at in the backup space, a backup has a unique workload compared to a primary workload. That's because every week there's a backup you take and there's a garbage collection every weekend. So there's a method to that which doesn't fit with the actual storage arrays or storage, especially the solid state drives or the flash drives. Now, how do you make sure that the solid state drives or the flash drives wedge well with the backup workload, like a primary workload? And that's where I kind of did a research on the workload analysis pattern as to, hey, here is a workload which is unique. How does it fit into the flash drive or NVMe drive? And then make it adapted, right? Adapted automatically. I did a lot of heuristics building in there. And now fast forward that to an AI. And AI also has a similar problem, but it is kind of quadrupled or it's even more because AI is very dynamic and unpredictable. So how do you make sure that this workload, which is dynamic and unpredictable, fits well with the infrastructure which is provided? In this case, let's say a GPU or a compute, which is very much a static. So how do you make sure that you make this also dynamic or adapted to the workload that is being pushed, right? So that is where it triggered. And the problem that kind of makes this dynamic and unpredictable, the result of this problem is you are not able to maximize your GPUs. Like whatever GPUs you're running, they're not maximized because it's very hard to go and guesswork and estimate what is the workload and then what fits into the GPU, and then you can increase the utilizations, right? So that hits directly your bottom line, your ROI, everything. And that's kind of made me and the team to start working on this particular solution. Yeah.
And I've known Anil for almost a little over 5 years now, but we got introduced by some friends, and I've been really excited to hear his thoughts even back then, and as the platform's matured. Now, I've been in the industry for quite a while, very much infrastructure, kind of evolving to infrastructure software and data, almost always data problems. And how do we get more value from data? And I think a lot of us have passion around that. As I kind of joined Anil in the sense of an advisor for multiple years, it just got more and more exciting, getting the trial customers, hearing that feedback, just really watching Anil and team, evolve the solution. Seen a lot of customers, a lot of trial customers, and then I joined a little bit more than a year and a half ago, as we started to really make progress with some of those early customers, and now coming formally kind of stealth November a year ago. We've just been having a blast, and nothing simple, but actually we're one of the few things our customers accuse us of actually simplifying things in their world. So I shouldn't say nothing simple, but we're having a lot of fun and getting some neat attention. But you guys are spot on with topic of your show. So looking forward to talking about all things inference, the good, the bad, and the ugly. And I'll turn it back to you guys.
A year and a half ago, that's like a lifetime in this era. And when you think about the scale of the problem, the industry has shipped almost $500 billion of GPU systems, right? And so when you look across enterprise inference today, what do you see as the core bottleneck holding back scale and performance?
Now, let me just take it from a high level. Calvin, you and I are thinking along the same lines. I actually have been using that phrase, well, the number goes up, every 3, 4, or 5 months. But yeah, we're looking at $500 billion GPU infrastructure, GPU servers, et cetera, all the stuff that surrounds it. And in reality, we're seeing true GPU utilization, being in that, 20%, maybe 30, maybe 40. But I think everybody we've talked to admits it's somewhere down in that zone. So, you think about 300, 400 billion of that not being utilized. And then you throw on top wow, inference is really just kicking off. And last I checked, inference is supposed to be 8, 9, 10x the amount of what we're going to see versus the current mix of training, fine tuning, agentic training, et cetera. Whatever those numbers are going to be in 3, 4, 5, 10 years when it's really all inference. And to see that utilization rate so low. So I look at that as a symptom, right? That's a symptom of some real challenges.
In addition to that, like what Charlie mentioned, which is kind of a utilization or the maximizing it, what the industry is moving towards or what we are seeing is more kind of agentic workload, right? So that's what everybody keeps talking, or even the customers are moving towards that. But the challenge with respect to the agentic is two things. One is our theme or the problem that we are after, which is like dynamic and unpredictable. Agentic is also is that wherein there is a cause, there is a reason, and now you're supposed to act, right? And that results into a lot of reasoning models. So it means that what, like, you are going to generate more and more tokens to resolve it. And then the other problem with agentic workloads is you have kind of what is now called as like either MOE or multiple agents working in parallel in MCP. So that results into even more dynamism at the infrastructure level, right? That's what people are complaining about, or people are even looking forward to how the infrastructure is going to adapt to that. That's one thing which we should look forward in 2026. That should be the next year should be even more fascinating to what we had in 2025. Yeah.
That makes sense. And then kind of moving to making this really tangible for our audience, do you want to describe more about the product, your approach, and then just case studies? I know you shared a few about the impact that you've had with customers.
We're kind of getting there, right? And Anil has talked about it. This fundamental thing where these AI workloads are unpredictable and dynamic. If we look at infrastructure, we're kind of evolving away from what was largely a static allocation method. And then I'll tee up a couple other things here, but it's like when we look at the number of variables on trying to get this very expensive infrastructure right for your individual model or for your multiple inference models in an inference server, and not knowing what that inference requests are going to look like and the volume and the shape and the size of them and the timing of them. So those two things are kind of immiscible, right? It's like you've got dynamic and unpredictable, and then you've got infrastructure, which initially starts out as very static, and many of the allocation and setup and provisioning tools of that nature. So just kind of the question you asked, Calvin, I'll turn it to Anil now. You see that dichotomy, I guess, and that's where we're living in there, and right in the middle of that to solve all that, all the way from where the AI workload, in this case, the inference requests and query payload, versus this really expensive, rapidly growing, incredibly capable infrastructure. And how do we get those two things and solve all those variables, many of which are changing in real time, and optimize and maximize each of the infrastructure for each individual model, which can be very different. But yeah, it's just my high level take on that. And then Anil, you can certainly talk a bit more about specifically how the platform really addresses it and other technologies we're seeing out there that are kind of inspiring.
A couple of things that even with respect to the problem, right? Like if you were to think, how is this tangible? Like whatever we're discussing with respect to the AI workloads being dynamic and unpredictable, and then the infrastructure, which is kind of a static, is if you were to put it to like a tangible ROI, right? There's anecdotal evidence. There is evidence from customers too, which are feeling the pain. Is that a 5% drop in a utilization of a GPU, whatever you're running, results into almost like $200,000 for a $2 million investment. What you have done. So now imagine, because with respect to the utilization, if you're not able to maximize it, that results into a less number of tokens that you're able to generate or summarize, right? So the inference, whatever you're doing, it's going to reduce. And that results into actual ROI that you are supposed to get out of that infrastructure, whatever you have. The idea here is to maximize as much as possible. So coming to our product, what we have done with the theme, like as we said, why not we straight away go into the workload, look into the workload, like basically look into the model itself, right? So the model has two characteristics. One is it is taking the data sets of data and then applying the algorithm. And when it pushes it down to the compute, it's going to form in AI terms more like a matrix multiplication, right? It's going to make it as a matrix multiplication and then push it down into the GPU level for it to go and then compute. So that results into a workload, and then there is a pattern to that workload, right? So now why not we look into the workload that is coming down, right? An example is, hey, how many number of input tokens it is pushing down, right? Like the prompt has how many number of tokens, or if you were to pick an image, what is the size of an image? What would be the matrix that's going to build on top using that, right? Or what would be the batches of tokens you're going to send it? What we do is that we, in a continuous fashion, we observe, do an analysis of that model workload specifically, and then based on that we go and then apply our AI model, which can go and then recommend, hey, these are the things what you need to get the maximum efficiency. Like it could be a GPU type. Okay, you are supposed to use, let's say, an NVIDIA Blackwell or an H100 or an AMD EMI Instinct, right? Why? And we give a reason why you are supposed to use that, and what would be the number of cores inside the GPU, what would be the number of stream multiprocessors or a compute units that you're going to need, and how much memory. So all that is kind of recommended based on a simple notion of this is the workload. And then as the model changes, let's say instead of you telling instead of you having a prompt, let's say of 200, now you've changed the prompt to, let's say, 400, or your output tokens go from 1000 to 2000, or your context sizes change, right? It should be dynamically adjusting. So that's what the first phase, what we do as part of our product. We are continuously observing, doing the analysis of the model and model workload, and then apply an AI model to go and predict and recommend the exact amount of resources and type of resources required. Once that is done, now we go and then, since we are able to do that, now how about we go and optimize it? Since we have this, instead of the user doing applying the optimizations, can we apply the infrastructure optimization as to, again, coming to the resources, which is amount of cores, SM, CUs, memory, what would be the KV cache, which is very prevalent now with respect to inference. How much is the prefill? What is the decode? Should I be disaggregating it, right? All that, right? So all that is kind of optimized. Apply some cool techniques to make it even better, and then hand it off to an orchestration layer, which we have, the third piece, which is, now can I go and then maximize it in a GPU? A simple example is, can I apply a virtualization abstraction layer wherein I can take multiple models, model inferences, and then multiple users, let's say, and then host them into a single GPU by partitioning it. So the user doesn't have to do any of this grunt work, right? So it benefits the data scientist or engineer who is deploying the models, not to worry about guesswork or estimation. It even helps the ops or IT or ML ops or cloud ops. They don't have to worry about, hey, what would be the scaling of this infrastructure based on the workload. What would be my resource planning? They don't have to worry about. Everything is kind of taken care automatically. And then, as I said, the benefits is tremendous. Instead of you running one model in a GPU, automatically you can run multiple of them or multiple agents in parallel concurrently without any user intervention. That's kind of a overall solution, if you will, that what Rapt AI we have built. Yeah.
It's incredible. So infrastructure is becoming agentic now, and we're transitioning from an era at scale at all costs, right? Buy as many GPUs as possible. I want to talk about, like, why now? Why is utilization and orchestration becoming important? Why are people caring about optimization?
Anil, as you were talking, I'm thinking about so many customers we have visited and gotten to know so well. There was NVIDIA, one of their big shows in San Jose, but not this last year, but no, it was this last year. It was about scalability, or one of the themes was scalability. And I just like, man, everybody we've met, all the roles that Anil mentioned, they're maxed out. They're working 10, 20, 18 hours a day. I guess one of the things we look at is we try to see, like in inference, like how much time are people trying to spend doing this analysis to figure out, hey, I need to get this many inference models and these locations at these nodes and these endpoints, et cetera, et cetera. And then once it's up and running, it's like, oh my gosh, how am I going to make sure, the latency stays within tolerance? We've got multiple types of models within the same server. How do I deal with that? And so after we've, just talking to people at shows and meetings and our customers especially, we generally have this conversation. So after everything's up and they've seen it running in production, the cost efficiency and the increase in ROI is pretty obvious. Wow. Depending on the model, depending on their latency requirements, all these other things, we're seeing, 4 or 5 times the number of models. We're seeing 8. We've seen customers say even up to 14. It depends on the GPU, the model types, latency requirements, et cetera. But the conversation usually goes, whoa, okay, when we think about it, we used to be spending this amount of time watching and monitoring all of the inference models, all of the inference servers for issues. We're over provisioning. You guys have helped to solve that. But the cycles of manual or human intervention, doing kind of some trial and error, not really, it's just not easy. You can do it once, you can do it statically, but to be watching inference on an ongoing basis and figure out, what does this exactly need so I can be efficient? I'd almost say it's not really something a human should be doing. It is just a bunch of data points and variables. So I just want to share that that's kind of one of those outcomes that isn't obvious right up front, but there's so many higher order things that the data science side, the IT ops side can be doing, want to be doing. So when we can free up some of that time, or when other agentic tools can free up that time, it's like this deep exhale. It's just kind of a great thing to see people, see some delight in their very long days. And maybe the days don't need to be exactly that long anymore. But more importantly, they can focus on this higher order work. So not only how do you scale infrastructure, but how do you get more AI innovation into production and things of that nature. So just kind of a little snippet of what we tend to experience as people go through employing, this intelligent agentic solution for your infrastructure. It can be pretty dramatic on the improvement side.
Just to add to that, right? So, like, why now? If you ask, because it's kind of an inflection point wherein, let's say, 2 years before when a Gen AI explosion happened, like you even now you have it, like the OpenAI models are so it kind of proving that it is pretty valuable, right? So now what is happening with respect to the enterprise companies and like with enterprise customers, especially, is that, hey, can we take this route wherein we can use an open source model which is available in a Hugging Face, let's say a Llama model or a Mistral or DeepSeek, like, right? And then can I tune it into my domain and then run inferences forever, right? Like basically that's where it is. Why now has two things. One is 2026 is going to be the year of inferences, because the tuning part is kind of all the companies, enterprises are working on. And then 2026 and beyond would be all about inferences. Like it's going to be inference workloads more and more. Certainly the tuning part will be there, but it'll be more inferences. That's where the real thing is. The second is, again, coming back to the agentic theme. Agentic is like kind of a completely automates, like whatever AI is doing, it even takes it to an automation to a different level, wherein a human, whether it's like, as I said, like an engineer or an ops or like whoever is kind of managing all this, or even in the industries, across industries, they don't have to do it. It's kind of a cause, reason, and an action. So this results into more and more reasoning, more and more tokens, or more and more images, and that has again a bound on the inference, and then inference leads to the chaos at the infrastructure. You need to have control this infrastructure chaos at the infrastructure, and that's the reason why we feel this is the right time, and it's going to take an explosion into the inference much bigger. Yeah.
That makes sense. And it seems pretty obvious, and you've proven the use case and the capabilities. But do you run into any friction? Are there things that CIOs and CTOs get wrong? Or what would be the current barrier to adoption today?
It's an interesting question. I'd say, like, kind of going back to, I think, teams are running so hard and fast, it's hard to step back and find the time to go evaluate a new tool, an agentic solution. We had one customer, and it was really a lot of fun, but we got introduced by a partner, and the IT side really made it very clear their perception of the challenges. They couldn't quite get, the bandwidth from the senior level to say we should really evaluate a different approach, right? We've been doing the same thing, expecting different results, and we all know what that means. So I'd say that's a barrier. I mean, there's always other challenges too, but it's, you're trying to solve a problem with new technologies to free people up so they can do higher order work. Well, the problem is they're so darn busy because they don't have the tool yet, right? So I'd say that was one, for sure we've seen. And then, then I think there's just the classic things where companies are just trying to run their workflow. They're just trying to get their business done. And we see all kinds of workflows, right? And one recent customer, they were really skeptical because they had tried two different approaches from organizations they viewed as expert. They did listen to us and they heard how our architectural approach was a little different. And they said, okay, let's give it a shot. But I feel like we were very fortunate that they gave us a third swing at the bat, or we were the third swing at the bat. That's just from the human point of view and how busy folks are is probably the number one thing I'd point out. And it's just trying to make sure we communicate as clearly as possible. There are new approaches and there are new tools and new architectures to solve these things that weren't born in the previous eras, truly born in the AI era. That's kind of our mission, one of our missions of getting that word out.
Yeah, I mean, I think it's, you touched on this here and in sort of the previous comments as well, that I think what we're seeing across the industry, right, is, and we've heard this a lot, is it's the talent shortage. You just do not have the people who can do all of these things. Maybe you have the people who can do them, but if you do, they're already maxed out, right? And so, exactly, like, wouldn't it be great if we could have a whole team whose whole job it is to scale up and optimize our infrastructure? Great. Well, then you're Google, right? You're Meta. For everybody else, how do you solve this problem? How do you give them the tooling to sort of overcome that? Like, I need an AI engineer, ops team in a box who can like do that exploration, can do that for me. And so I'm not sitting here being like, man, I even know I want to do these things, but I can't drop everything. Like, as you said, because we spent so much time just getting to this equilibrium point. And as we know, change management, right, is like, oh man, anyone who's worked in IT is like, well, we have all this tech that we really like to improve it. Yeah, but what's that gonna do? How long is that gonna take? Do you know what's gonna be? Like, the ROI gets real messy. And so I think it's a really cool approach to try to solve this challenge of automating a lot of that sort of exploration.
Even the theme that when we started was that the AI engineers or the data scientists, who's running the AI models, they should not be looking into the AI infrastructure at all, right? Because they don't want to be tuning the infrastructure rather than they can work on the models that they're running, or they plan to serve or run it. That should be the focus. And then the more they start looking into the infrastructure tuning, which they are not supposed to, the more time goes in that. And that's where the productivity also decreases, right? That's another angle you can think.
And kind of also related to this, Cooper's question about like, what are people getting wrong? And I know we have some ideas like, oh man, the classic, just throw more hardware at it, throw more GPUs at it, get more GPUs. I think as you guys talked about, like, actually people have tried this and then they don't actually leverage them, especially in the age of inference, right? So maybe in the age of training, we are like, yeah, these things are running constantly. You're computing gradients. They're doing all this stuff. We can have that. But in inference, you have a lot of ad hoc workflows. You can't predict them necessarily. Again, with transformer-based models, maybe, I don't need context windows that are massive because my use case is really small and I can optimize on that. Maybe I have really big context windows. I can optimize around that. And then also, we know a lot for training, some of these newer chips like your Blackwells are great. And they can do okay, good on inference. But like, what about older hardware? If I made my investments, if I've got like a boatload of, I don't know, T4s or L4s or, 6s, or I've got A100s, like, is my mind that, oh no, we've missed the boat. We gotta throw all that away. Like, is that true? Or are you guys able to help people like leverage their older equipment as well?
Yeah, absolutely. Yeah. So we kind of, that's a very, very good point, Byron. So the problem what people face is, can I reprovision this to the models, whatever is being run, right? So that's absolutely right. Like that's one of the things that as part of the workload analysis and recommendation, we do say that, hey, you don't have to have a Blackwell or a H100 or H200 or high-end GPUs, because your workload is okay to run and then still maximize a T4 or a L40S, right? Which is not even 20% of the cost of what you get a H100 for, right? So, and the second thing is, sometimes you hit into the supply chain issues like GPU shortages. If you, as you described, maybe a Google or a Meta can have, or a large corporation can have access to thousands of these high-end GPUs, but for a small and medium business and for masses, that's not possible always, right? So they'll be in the queue or in the line. Can we reprovision some of these old ones and make the best use of it? We do that as part of the first layer itself, wherein we analyze and then analyze the workload and then provision them on the actual low end GPU. In fact, recently we did solve one of the customer problems wherein they were using the H100s in a cloud, and then the cost was pretty high, and sometimes it's not available. We moved them, run the workload transparently into an Ampere A100s at a 40% cost, right? So that's one use case that they were running some ASR models and all. So it is pretty substantial. The second thing is that what the enterprises also look for is the depreciation, right? Like, what would happen to the things that I've brought? The depreciation is pretty rapid because every 3 months, as we know, there is a new next gen coming in, right? It is not like a CPU. It used to take like maybe 2 or 3 years once you used to have a new version. But here, every 3 months, there's a new version or new model that is coming in, and then that depreciation rate for the older ones start going down. Right now, you have huge investments in your data center. Now, how do you make use of it? That's a valid point. I believe some of the companies who have got a lot of these older GPUs or the low end GPUs that we can reprovision automatically.
Great question, because so at a high level, it just comes back to this level of complexity out there, and it's perceived complexity now because every customer wants choice. Yet there's a perception, even generations of single manufacturing GPUs complex, or at least they're different. But everybody also likes to know that, hey, I may have these GPUs doing great at this workload. They might run into other workloads where other accelerators are available, and they may have some on-prem and in the cloud. So when you look at the number of GPUs that people would like to have available, if it was easy to implement and steer the right workloads, right accelerator, that seems like an impossible thing. But it's the point that I think Anil's reinforcing, and Byron, you mentioned, which is there's been a perception about a supply problem. We've been able to throw capital at this problem, and there's supply to some level. And we for a year or so have been saying it's not a supply problem, it's an optimization problem. It's a utilization problem. But it's even beyond that. It's a simplification problem. So, what are we lacking? Well, agentic capability, automation, things that take the human out of the loop a little bit on these more tactical things that can be done with, great machine learning and deep learning stuff. So that's why we're excited and getting just, great reception. People are saying, oh, wow, okay. AI powered GPU optimization and automation. That's here. People are doing all sorts of things along these lines. We've been at it a bit, and we feel pretty excited that customer-driven roadmap is going in the right direction and providing a lot of benefit now. But that looking in the future, there's another element that we haven't even touched on, which is just like power. We have a client that really needs to be running more models, which is almost every client we've run into, if not 100% of them. Yet they're kind of out of power. They can't roll in another rack. By the way, they have room. They've got space. When we were able to come in and say, listen, today you're lighting up 184 GPUs. When we look at that workload, we go, wow, let us come in, let us analyze your workflow and your models. And lo and behold, we're running those same GPUs on a third of that, or a quarter, or in some cases, a tenth of that GPUs. And they're running better. Every model's getting exactly the cores it needs, the SMs, compute units, the memory it needs. And as those models either evolve in a training sense, from needing a lot of cores to memory, but in the inference world, no matter what's coming in, as Anil said, multimodal, we're sensing it, we're analyzing it, and we're feeding each of the models in that inference server and even beyond exactly what it needs. And I think that's a scenario where, wow, I'm running my models, I'm getting a much higher tokens per second at an optimal latency, and my energy per token is dramatically lower. So a lot of cool things can happen there with a simple software solution. And that's what blows their minds is, you're solving power issues with software. Well, we're not solving the issues, we're just making it efficient. And so through that, yes, you're reducing your power draw. You're not having to light up all the GPUs. You're lighting up less GPUs, and you're only lighting up the parts of the GPUs your models require you to. So even there's power draw reduction within each GPU. It does seem like it can go on, but when you look at these individual vectors, it's time. Customers are hungry for a fix. If we can continue to communicate succinctly and get the attention of the right folks that are having the challenges, we see that we have a very high success rate.
Looking ahead towards the future, I think today it's quite obvious a lot of value is being created at that GPU hardware layer. And then you've got the foundation model providers. But why is this abstraction layer becoming more valuable, and where do you think it's heading?
One of the reasons why we need abstraction, which kind of becomes even more prevalent, is that it's not just one vendor or one GPU that you can go after because of, again, the cost availability, the power draw, So you can have multiple of them, right? So now I, as a user or an enterprise, I get the flexibility for me to go after, like as we discussed in the previous section, which is I can go after any GPU model and then run it transparently, right? So that if we were to push the envelope, and then I, as an user or enterprise, can I have multiple vendors who can service this, right? Not just the GPUs; it can be even the other next gen accelerators, right? Now the challenge is that if I were to go and then start thinking about it, then I, as the institution, need to have expertise to work on a certain, like in silos, like certain vendor, certain GPU type, or the vendor type. So now, if there is a layer which can come in and then say, hey, a workload is a workload, a model is a model, and that if I can go and abstract and then run it across any of these GPU vendors or accelerators, right? That's one of the reasons why we need the abstraction, and that becomes even more as the cost or the number of tokens, everything increase. People look for options. That's one. The second reason why we need abstraction is the complexity, right? The complexity right there, it is hitting at our face, is that there is so much of a driver library. There's packages that are there in each of these GPU types, and then I, as a AI engineer who is deploying my models, how can I need to have a deeper understanding, and in some cases, even though you cannot apply it to it, because let's say at 1 p.m. I'll get this many tokens, or this is the context window. At 2 p.m. it might change it, it might reduce it, right? So there's a lot of lightly used, over provisioned, underutilized, all the scenarios. It is very hard for somebody. So is there any way we can have an abstraction which is built down about these GPUs, wherein it can take all the burden? Hey, a workload is a workload, a matrix is a matrix. So let me best fit this into the GPU so that I can maximize it. That's one of the reasons why. That's one other reason why you need an abstraction like layer that we have. Yep.
Any bold predictions or thoughts about 2026 before we wrap?
I was just going to compliment something or ask Anil maybe to even expand on it. It's like there is this other interesting element in the industry where there's some very common tools that show a certain amount of utilization. And then I think Google coined the term, this phrase, true utilization. And so I think some of the really exciting things when you talk about abstraction is, there are examples in the industry, and Neil and his team are one of them, to abstract not only the different manufactured GPUs, but the GPUs themselves to a granular level. We're seeing constantly where a workload may take a whole bunch of GPUs purely for the memory, but there could be other GPUs that could be leveraging the processing power or the SMs and things of that nature. So, Anil, I didn't know if you wanted to comment on that at all, but it's this subtle little thing. People think general utilization, that's fine. But in reality, there's multiple issues when you just allocate a percentage of the memory, assuming that the rest of the whole GPU goes along with it.
There's unless, like as Byron mentioned, if you're in a Meta or a Google, maybe you have kind of a deeper knowledge of this, right? An example is that whatever tools that are out there, if you use, hey, we have seen in some cases the customer or enterprises or users say, looks like I'm able to get 60% or 70% utilization. So like you as a product, like you can push it to 90. That's the case. But the scenario is the 60 or 70%, whatever, if somebody were to say that they're getting it, that's kind of not really it. Like utilization is kind of a misused term, the way the tools are kind of telling it, because utilization really doesn't say the actual resource, what you're utilizing. It is whatever resource that you're using at that point of time, how much of that you're using it. Let's say in a 5 minutes time window, I'm using only 10% of the cores. It says, hey, you're using 90% or 80% or 100% of the 10% core. It really doesn't tell that, hey, you're using actual 5,000 cores or 10,000 cores, right? So that's kind of a misconception that people get into. And then using our tool or our product, when we go and observe and then say, hey, really, this is not what it is supposed to, thereby the 10 or 12%, their eyes pop like, hey, we thought we were using 60%, but in reality, we're not using 12%, 14%. And that's where we come in and then say, hey, now why don't I really increase it from 14% all the way to 98%, right? So that's another benefit that we kind of approach the problem to. Because of that one layer, which is the main IP that we have, which is analyzing it and then observe and then recommend. So we get the ability to do all this nice things. Yeah. To answer the other question, what do you see the predictions, bold predictions in 2026 and then beyond? Moving forward, I think it will be the age of power soon becomes the number one problem too. Because now what is happening is that you have all these data centers that are being built and then funded and then like sovereign AI. There's so many things that are going on that will still continue. But I would say if I were to look 2-3 years down the line, it'll be the power becoming a challenge. It used to be like tokens per second to dollars, like a number of tokens per dollar per hour. Two, it'll be like tokens on the watts, right? How much power you're drawing to generate this many number of tokens, right? And that's going to be the next goal, like everybody will be looking after, right? And then we believe that we are kind of prepared to that because, like as Charlie also mentioned, that as we are working on these problems, we have an impact. We have I would say, a positive impact and even more profound ease on the power too. Like with our precise allocations, with the analysis that whatever we do, we are able to say that, hey, the power draw should be less, only precisely. And I would say that will be one of the themes that people should watch out in 20. I would say 26 and beyond. Maybe in another couple of years, that will be one of the biggest issues cropping up. Yeah,
I'm glad you brought up power because I think a lot of times when we're talking about optimization and things like that, people don't often connect it to the real human, problem we need to solve. We have very real constraints in this world. And I think at this point, MIT did a study, if I recall correctly, AI is using about a quarter of the energy, like about as much electricity annually as a quarter of the US households. That's incredible. So not only should we optimize, and it's not just about bottom line impact for profitability, we have to do this for our planet and our world. So this is a really important problem to solve. And then, as I think about heterogeneous hardware environment and the rise of open source models, I think it's not just can we build a more heterogeneous infrastructure. We should not have tyranny of one major model, provider or one major chip manufacturer. So I guess that's what I would say. My prediction is not only is it happening, but we also should accelerate that progress.
We should do it. Like, I think a lot of us walk around just saying, gosh, we need to get to fusion. We need to get to fusion. But the reality is, it is screaming for optimization. So, when I look at 2026, very similar, and Neil and I talk about this a lot, we're seeing it, we're feeling it. Our people that like to hear about our solution or that have our problems are certainly some on the data science side, for sure. There's some frustrations there, and certainly on the IT ops, ML ops, cloud ops. But one of the more prominent kind of personas is tech finance. Smaller companies, even CFOs and whatnot are going to some of these shows to try to figure out, what are the solutions and how can we be more efficient? And so all these things are coming out. So number one, kind of that irrational consumption that we saw way back when, that's come home to roost, like where people are saying, okay, where's the ROI? We're spending lots of money. So certainly you have these two different classes, right? The enterprises, the global 2,000 corporations that are trying to drive business and all the new startups. And then you got the foundational model folks. But we're seeing it on both sides that, that return on investment is becoming important. But right next to that are those things like power. And we're not going to solve all of them, but solutions like ours can be a little bit of an easy button and literally be dropping for your current workloads, dropping your power by 20, 30, 40, 50, sometimes more. And it's not rocket science, but it's not easy. So that's why our solution, we have all that knowledge, both on the infrastructure side and what that software needs. So we're able to do that. And it does feel good that we're saying, hey, let's get these not only maximum tokens per second at the right latency, but let's also make sure that's the lowest energy per token. Watch all those metrics. And so that's what makes us happy too, when people really kind of see that that's possible and are winning on multiple fronts, or people are getting more time back. So as I look forward, I think you're spot on. The energy is so important. We haven't pounded the drum on that because technically not normally our space, but more and more that's coming up in our marketing because customers are reinforcing that. But that other side is just the ROI. And I think that's those are the two things I see. 2006, the volume knobs on both of those are going up. And we're happily able to address those, and more agentic solutions in the industry are going to start to address those. It'll be exciting, and the only thing we all know is forecasts are never right, and predictions are only correct in certain degrees. So, but it feels like those two are pretty probable.
Happy holidays, gentlemen. Thanks, Charlie and Anil, for joining us today. For listeners who want to go deeper, we will include links in the show notes. If you enjoyed this episode, be sure to like, share, and subscribe. Thanks again for tuning in to Inference Time Tactics.